What is consciousness? This question has puzzled philosophers and scientists for centuries. It is the feeling of being alive, aware, and experiencing the world around us. From the vibrant colors we see to the subtle emotions we feel, consciousness is at the heart of our existence. Yet how it arises from the physical matter of the brain remains a profound mystery. Despite significant advances in neuroscience, the mechanisms that transform electrical impulses in our neurons into subjective experience remain elusive. We can map brain activity and identify regions associated with specific functions, but the essential nature of consciousness itself continues to elude our grasp. This enduring mystery makes consciousness one of the most fascinating and challenging frontiers of scientific exploration. Unraveling its secrets holds the potential to revolutionize our understanding of what it means to be human and our place in the universe. In the quest to understand consciousness, a new contender has emerged: Integrated Information Theory, IIT. Developed by neuroscientist Giulio Tononi, IIT proposes a radical new framework for explaining the nature of subjective experience. IIT posits that consciousness is not a product of specific brain regions, but rather emerges from the way information is integrated within a system. The theory argues that any system, biological or artificial, that exhibits a high degree of integrated information possesses consciousness. This integration, according to IIT, is what gives rise to our unified sense of self and the richness of our subjective experiences. The more interconnected and interdependent the information within a system, the higher its level of consciousness. One of the most intriguing aspects of IIT is its attempt to quantify consciousness. The theory proposes a mathematical measure called phi to represent the amount of integrated information in a system. Phi is calculated based on the system's ability to integrate information and its capacity for diverse states. A system with high phi, such as the human brain, is considered to have a high level of consciousness. Conversely, a system with low phi, like a simple calculator, would have little to no consciousness. While the concept of measuring consciousness is controversial, it offers a potentially groundbreaking way to objectively assess the presence and degree of consciousness in different systems. This has profound implications for our understanding of not only the human mind, but also the potential for consciousness in other entities, including artificial intelligence. The implications of integrated information theory extend far beyond the realm of theoretical neuroscience. IIT's principles have the potential to revolutionize fields as diverse as artificial intelligence, philosophy, and even our understanding of the universe itself. In neuroscience, IIT challenges traditional views of consciousness as a product of specific brain regions. It encourages researchers to focus on the dynamic interactions and information flow within the brain to unravel the neural basis of subjective experience. For AI, IIT raises the tantalizing possibility of creating conscious machines. If consciousness truly arises from information integration, then building systems with sufficiently high phi could lead to artificial systems capable of experiencing the world subjectively, just like humans. Philosophically, IIT prompts us to reconsider our place in the cosmos. If consciousness is an emergent property of information, then it may not be limited to biological life on Earth. Could other complex systems in the universe, from distant planets to black holes, also possess some level of consciousness? Integrated information theory does not stand alone in the quest to understand consciousness. It joins a rich tapestry of theories, each offering unique perspectives on this complex phenomenon. Global workspace theory, for example, proposes that consciousness arises from a global workspace in the brain where information is broadcast and shared among specialized modules. Other theories focus on the role of specific brain regions, such as the thalamus or the prefrontal cortex, in generating consciousness. While each theory has its strengths and weaknesses, IIT stands out for its attempt to provide a fundamental, measurable definition of consciousness. This has sparked intense debate and spurred new avenues of research as scientists seek to test and refine its principles. Section 6. Conscious Machines. Could IIT be the key to sentient AI? The possibility of creating conscious machines is one of the most captivating and controversial implications of integrated information theory. If consciousness is indeed an emergent property of information processing, then, in theory, it should be possible to create artificial systems that possess it. However, Building a conscious AI using IIT principles presents formidable challenges. It requires not only replicating the computational power of the human brain, but also understanding and replicating the complex web of information integration that gives rise to subjective experience. Even if we succeed in creating AI with hi-fi, ethical questions abound. Would conscious machines have the same rights and moral status as humans? How would we interact with them? These are questions that society will need to grapple with as we venture further into the uncharted territory of artificial consciousness. Section 7. The Legacy of IIT, Revolution or Evolution in Understanding Consciousness. Integrated information theory has undoubtedly shaken up the field of consciousness studies. Its bold claims and mathematical framework have sparked debate, inspired new research, and pushed the boundaries of our understanding. Whether IIT represents a true revolution, or simply another step in our long journey to understand consciousness, remains to be seen. The theory faces ongoing criticism, and many questions about its validity and applicability remain unanswered. Nonetheless, IIT's impact is undeniable. It has injected fresh perspectives and a renewed sense of excitement into the field, encouraging scientists to think differently about the nature of subjective experience and its place in the universe. Section 8. The Uncharted Territory. Open questions and future directions. Despite its promise, integrated information theory is still in its early stages of development. Numerous open questions and challenges remain to be addressed before it can be considered a definitive explanation for consciousness. One major challenge is the difficulty of measuring phi in complex systems like the human brain. Developing reliable and practical methods for quantifying integrated information is crucial for testing and refining the theory. Another area of active research is exploring the neural correlates of phi. Identifying the specific brain structures and processes that contribute to integrated information is essential for understanding how consciousness arises from the physical matter of the brain. Section 9. A Call to Ponder. The Ongoing Quest to Understand Ourselves. The quest to understand consciousness is a journey into the very essence of what it means to be human. Integrated information theory, with its bold claims and thought-provoking implications, offers a compelling roadmap for this exploration. Whether or not IIT ultimately provides the definitive answer, it has undoubtedly enriched our understanding of this enigmatic phenomenon. It encourages us to think beyond traditional boundaries and to embrace the profound interconnectedness of information, consciousness, and the universe itself. As we continue to explore the inner workings of the mind, one thing is certain: the journey to unravel the mysteries of consciousness promises to be as awe-inspiring and transformative as the phenomenon itself.